Okay, we are going to start out this review by actually covering a homework assignment, not a test assignment. And the reason why is because the tests that are available on D2L, the ones with the answers, they don't have any content or any problems that are related to ASCII, Unicode, and UTF-8. Those items were actually added in the fall of 2020, and we don't have any problems, any answer keys for tests of that time. So we're going to start out with this homework here, starting out with problem number 1. Now, problem number 1 is pretty straightforward. What it's saying is you have picked out a byte in the middle of a stream of UTF-8 bytes coming at you. And there are 5 different ways that one of these bytes can start out. If it starts with a 0, this is a 1 byte UTF-8, and it maps directly to the 7-bit ASCII codes. If you remember, the 7-bit ASCII codes, if sent as a byte, they all start with a 0. That makes it so that ASCII maps directly to UTF-8 whenever it's just staying restricted to those 128 patterns of 1s and 0s in 7-bit ASCII. Now, the next thing you might find in a byte is something that starts with 1, 0, and then you're left with 1, 2, 3, 4, 5, 6 bits as the payload to carry the Unicode code point. But this 1, 0 identifies it as the second, third, or fourth byte of a multi-byte stream. All right, you're missing the first byte. The first byte will tell you exactly how many bytes to expect, and then the 1, 0 is going to tell you, is going to begin each byte following that. And there's a couple of reasons for this. One of the reasons, which we'll talk about in a minute, is that it allows us to actually decode a Unicode 8 backwards. Because if we see 1, 0, then we know, okay, we're going to hold on to that byte and see what the next byte is. And if we get another 1, 0, we're going to hold on to that byte, and then we'll see what the next byte is. And if we get a 1, 0 after that, we'll hold on to that byte. And then, after we get a sequence of these second, third, or fourth bytes of a UTF-8 sequence, then we're going to get one of these patterns. We're either going to get 1, 1, 0, 1, 1, 1, 0, or 1, 1, 1, 1, 0. Now, these guys represent the first byte of a 2-byte sequence. So if we start with 1, 1, 0, that'll be the first byte of a 2-byte sequence. If we start with 1, 1, 1, 0, it's the first byte of a 3-byte sequence. And if it starts with 4 1s and a 0, we know that it's the first byte of a 4-byte sequence. All right? Now, the rest of the bits, just like in that second, third, or fourth byte, the rest of the bits of these first bytes carry payload. They carry data, Unicode code point bits. So the first byte of a 2-byte sequence leaves 5 bits, 1, 2, 3, 4, 5 bits to carry a Unicode code point. The first byte of a 3-byte sequence, there are 4 bits there that are available for us. And then the first byte of a 4-byte sequence, there are 3 bits available to us. So this first problem is really quite simple. All you have to do is convert each one of these hexadecimal values to the corresponding binary value. Once you find out what the corresponding binary value is, you can figure out which of these 5 patterns it starts out with. So let's start out with the 7A. 7A in binary is 0, 1, 1, 1, 1, 0, 1, 0. I don't have a whole lot of room here. I guess I could expand this out a little bit. So that means since it starts with a 0, it is a single byte UTF-8. Just simply check that box or select that on the D2L test. All right. Now, D4. D in hexadecimal is 1101 in binary. And then we have the 0100. That is the rest of that number. Now, we don't actually need the bits. We just need enough bits decoded so we know which one of these 4 or 5 patterns it's going to be. And it turns out since D starts with 110, we know that it is the first byte of a 2-byte sequence, right? 2-byte sequences start with 110. B2. B2, B in hexadecimal is 1011 in binary, and 2 is 0010. Once again, we only needed to decode enough bits in order to know what the starting pattern was, and you'll see that this starting pattern starts with 10, which means it is the second, third, or fourth byte of a multi-byte sequence. Then this last one, F6. F is 1111, 6 is 0110. So we see that the first 5 bits of this are 11110, identifying it as the first byte of a 4-byte UTF-8 sequence. All right, so there's the answer to the first problem. Now let's take a look at the second problem. Second problem, true or false? It is possible to decode the byte stream from a UTF-8 encoding backwards if necessary. Yep, sure is. That's what we talked about. If I grab a byte out of a byte stream, and I have to know that it is coming backwards. So as long as I know that it's coming backwards, I can do the decoding. So I get a 10 and then a byte, the first 2 bits of a byte are 10. I know that it's just one of the bytes that follows one of the first bytes of a multi-byte sequence. If I get another 10, I just hold on to it. I keep holding on to the 10s until I get the identifier, which tells me how many bytes I should have expected to receive. So if it starts with 110, that's 2 bytes. 1110, that's 3 bytes. 11110, that's 4 bytes. All right, so yes, actually it is true. We can decode a byte stream from UTF-8 encoding backwards. Next thing, problem number 3. How many different patterns of 1s and 0s are part of the original ASCII standard? Well, the original ASCII standard was 7-bit. They all started with a 0, and then you had a 7-bit payload, right? Well, how many patterns of 1s and 0s can you have with 7 bits? Well, that's 2 to the 7th, or 128 patterns. All right. Problem number 4. The Unicode code point for a lowercase pi is U plus 03C0. Now the key is this 03C0 is hexadecimal. So a hexadecimal 03C0, the very first thing we need to do is convert it to binary. Let me tell you why after I do the conversion. So we have 0000, and then 3 is 0011, C is 1100, and 0 is 0000. Now, the reason we need to do the conversion to binary first is we need to know the minimum number of bits it's going to be required in order to send this code point. We see that we go we're starting at the right-hand side, we go all the way up until we reach this most significant one. Now, that most significant one is 10 bits into the sequence, or in other words, we have at a minimum, if we delete all the leading zeros, we have a minimum of 10 bits that are required here. Well, let's go back up to our problem number 1 where we talked about the bits of a payload. The ASCII had 7 bits. If you have a byte and you take away the first bit that has to be a 0, you have at most 7 bits that you can transmit. What about 2 bytes? Well, 2 bytes, I have the 5 bits that can be in the payload, and it can be part of the payload of the first byte, and then the second byte is going to start with 10, which gives me an additional 6 bits. So I have 5 plus 6, or 11 bits that can be sent with a 2-byte sequence in UTF-8. 3-byte sequence. Well, a 3-byte sequence has the 4 bits that are in that first byte of the sequence. So there's 4. We got 4, and then we're going to have 2 bytes trailing that start with 10. Each of those 2 bytes is going to have 6 bits. So we have 6 plus 6 plus 4. The 6 bits from the third byte, the 6 bits from the second byte, and the 4 bits from the first byte, which gives us a total of 16 bits. Sorry, things are getting a little bit crowded in here. So we've got 7 bits for 1 byte UTF-8, 11 bits for 2-byte UTF-8, and 16 bits for 3-byte UTF-8. What about 4 byte? Well, in 4 byte, we're going to have 3 bytes that start with 1, 0. So that'll be 3 bytes that are going to give us 6 bits apiece. So 6 times 3 plus the 3 bits that are available in the payload of the first byte. So we'll have those 3 bits there. So what we've got is 6 times 3, that's 18, plus 3, that's 21 bits. So this gives us the different requirements. And we come back down to problem number 4. Problem number 4 says, well, I need 10 bits. What is the smallest sequence that will allow me to transfer 10 bits? Well, 1 byte UTF-8 is too small. It only goes up to 7 bits. 2 byte UTF-8, however, that allows us 11 bits, which is enough to carry the 10 bits of the lowercase pi. So 2 bytes is enough. 2 bytes is exactly enough. Well, not exactly enough. It's actually a little bit more than we need. 1 bit more than we need. But that is the answer, 2 bytes. This brings us to problem number 5. Now, problem number 5 shows us a byte stream in UTF-8. All right? And what we're supposed to do is distinguish the control bits, the ones that identify what type of byte this is, from the data bits, the code point bits. Now, if we start on the left-hand side, we'll see that the first bit is a 1. That means it's not an ASCII 7-bit single byte code. Second bit is a 1, and then the third bit is a 0. So this 110 here, that identifies it as a 1-2 byte sequence, which is cool because that's how many bytes we've got, right? The next 5 bits of this 2 byte sequence, or excuse me, the next 5 bits of the first byte of the 2 byte sequence, those are data bits. Those are the Unicode code point bits. That brings us to the second byte. Now the second byte and the third byte and the fourth byte always start with 1, 0. So we take those out of the equation, and these bits, the next 6 bits, those are the bits of our code point. Now, in a paper copy, all you were supposed to do was underline this. But on the D2L quiz or D2L test, you're going to be asked to specifically put those bits down. So the first 5 bits of our 11-bit sequence are going to be 0, 1, 1, 1, 1. And then the next 6 bits are going to be 0, 0, 0, 0, 0, 0. So that right there is the sequence that's being carried along as a payload for this 2-byte UTF-8 sequence. Now we're going to do exactly the same thing with this problem number 6, except we've got a longer sequence here. How long a sequence do we have? Well, let's take a look at this left-hand side and just start decoding the bits. We've got a 1, a 1, a 1, a 1, and a 0. Those 5 bits identify this as a 1, 2, 3, 4 byte sequence. So the next 3 bits right there on a paper copy, we just underline them. That's actually part of the payload right there, the 000. Those are the most significant 3 bits of the payload of this 4-byte UTF-8 sequence. Now the next byte is gonna have to start with 10, so we know that those bits are control bits. We ignore them. These next 6 bits, we don't ignore them. We make sure that they're a 10, but we throw them away because they're part of the control sequence. They're not part of the payload. And we see that 0, 1, 1, 1, 1, those are the next 6 bits of the sequence. Going on to the third byte. Also, it must begin with 10. Those control bits are discarded, and the next 6 bits, those are the bits of our data. And then we go on to the last byte. Once again, starts with 10, we discard those bits, and the next 6 bits, those are the bits of our data, of our code point. We copy these bits on a D2L or quiz or D2L test, and we get from here 0, 0, 0. From the second byte, 0, 1, 1, 1, 1, 1. From the third byte, 0, 1, 0, 0, 0, 0. and from the fourth byte, 110101. And that's the answer to problem number 6. Now, hopefully this understanding of UTF-8 and how the code points work and how the data fits into the different bytes of a UTF-8 code stream, hopefully that all makes sense. If not, we've got plenty of videos for you to watch to see if you can decode them on your own.